Okay, just a recap, okay? Let's see if you can help me out. What is the definition of accuracy? How close, right? How close your measurement is to the target. Okay, there's an actual value of that thing that you're trying to measure, and your measurement, right, the accuracy of your measurement is dependent on how close you are to the target. And what affects the accuracy? The unit affects it, the scale affects it, the operation of the device, and the device itself. Okay, those are the four things that affect your accuracy. I know it's small, but I just want to like recap here. So that's how we started our whole unit. And then I talked about precision. What would you define precision as? Try to be as short of a sentence as possible. What's precision? Smallest increment, smallest unit you can go up or down by, yeah. So I'll just call that smallest increment. Increment is the fancy word for how much it goes up by. And you can do a little example on your study sheet. If, for example, 0.00 kilograms, right? Your precision is 0.01 of a kilogram, right? It's defined by that decimal, the place, if it's a value. If it's a picture, right? You might want to do this is 0, and this is, I'm going to go 20, and let's make a marking in between. I know this is small, I apologize, but this is like, imagine study sheet entry. What's the precision of this thing? Remember, it's from marking to marking. I will make a note here. Marking to marking. This is getting very, very crowded here, but that's what your study sheet is going to look like. So you're curious from marking to marking, how much am I going up by? Okay, so in this case, what would you say? Mental math. This has to be 10, right? And so we're going up by 10 every time. So precision is 10 milliliters, let's say, when you have that scenario. Remember the cheat I gave you for a diagram? It's not a cheat, it's a formula. We're not cheating in here. The precision is, what did I tell you again? High minus lowest, yeah. So you pick a high number, you pick a low number, and then number of gaps in between. Okay? That is how you figure out the precision when there's a diagram and it's kind of hard to guess. Maybe the mental math, there's a lot of gaps in between and you're like, I don't know, I don't know exactly. Use this. Okay? And additionally is uncertainty is the margin of error. Uncertainty is precision divided by 2. Also note, precision and uncertainty are related in a certain way. Where you divide by 2 to get from precision to uncertainty, you multiply by 2 to go from uncertainty to precision. Okay, so that's another study sheet entry. To me, this is still too big. Like for a study sheet, I would try to like compress it even more, but I need you to be able to read it. So right now I'm just keeping it like that. So I hope this helps. I would say if you have this, you're in very good shape. You're in very good shape, okay? For this unit, like you could probably score quite a few marks on the exam already just by having this, okay? It's not it, but it's a good start. Okay, so we want the precision and the uncertainty in every single scenario. And I'm doing a lot of diagrams here because those are harder. So I basically just look at this from 5 to 10, I go up by 5, I go up by 5. My bad, these markings here were not supposed to be there. So I apologize. Precision is 5 ml. Uncertainty is plus or minus 2.5 mLs. I'm not going to do every single one. But here I go up by a teaspoon, right? 1, 1. So precision is 1 teaspoon. Uncertainty is half a teaspoon. That's it. This one here, the one that comes next, is I'm not too happy with that one. I did say omit the dots, just focus on the numbers. So I want you to just think it's like it's going up by 50. It's going up by 50. So if you just look at the numbers, the dots are kind of weird. They're not equally spaced out. You will always have equally spaced out dots or markings. So I just tried to make it relevant. So I walked around. This was my toaster oven. So precision is 50 degrees Fahrenheit, and therefore uncertainty is 25 degrees Fahrenheit. Okay? You know what? The province likes clocks for some reason. If I gave you one of these, if you could just write it down. If that's the only clock you had, what would be the precision of this? 3, right? 3 hours. Write down clock because you're like, what is that? Never seen something like that, right? That's a clock. I don't know, these days we all have our phones. We don't even use those anymore. 1.5 hours would be your uncertainty, right? Plus or minus. So it's going to get kind of strange. It's like, if I'm going to get you start thinking about that. If the short arm, right, the hour arm, if it were to be, maybe don't copy this part right here, but if it were to be here, in this unit, if I asked you what's the time right now, what would you say? You'd probably say, well, if this is 3, then this is 4, this is 5. It's probably just after 5, right? That's what you would say. And this unit is very weird. Which one is this one closest to? 6. So we would say 6 o'clock. Weird, right? But that's what we're going to do in this unit. Not so much with time. We're going to do that with other measurements. We're going to round to the nearest marking, right? So whatever is nearest. So just get ready for that. Let's keep going. Let's go with this one here. This one here. This is my barbecue. It's all fogged up already. Right now I can't even see the numbers anymore. That's how much water is in there. Should cover it when it rains. Okay, what's the precision here? This is where I like to use, I mean, some of you already figured it out, I know, right? But I will say that this is a high, let's say, and you pick, let's pick the 400 as our low. Can you see that? Okay. So you would go 500 minus 400. One, 2, 3, 4. So this is 100 divided by 4, which is 25 degrees Fahrenheit. It says it up on the screen on the top of this picture that it's in degrees Fahrenheit. So your precision is 25 degrees Fahrenheit. Your uncertainty is 25 divided by 2, plus or minus 12.5 degrees Fahrenheit. Okay. So that's how that goes. If it's tricky, use this formula to help you out. Some of them are unfair. I'm going to skip. What would be the precision of this? What's the smallest increment? This is a bit of a trick question, but not really if you really think about it. From marking to marking, I mean, the markings are not there, so we go from here to here. What's the smallest amount that can go up by? Can we go up by hours? Are we going up by hours? Or we've got the long arm too, the minutes. How many minutes at a time? Technically 5 minutes, right? At a time. So my key is probably wrong. Did it say a minute on the key? It's 5 minutes, technically. There was no key? Low key? Low key key? Anyways, there was low key, no key. Anyways, precision is 5 minutes. Because I go up by 5 minutes at a time. There's a long arm there. So basically what I can read, it's weird, it's strange, I know, but it's 5 minutes at a time, right? 5 minutes, 5 minutes. If only the short arm had been there, the hour arm, then it would be 1 hour at a time. So my key, whatever was there, I didn't update it, okay? So I don't think I have it like that, but I will make a note. Note due to the minute arm. If there hadn't been there, it would be 1 hour. Maybe let's make a note. Because the province does like clocks for some reason. I'm like, really, out of all the things, let's focus on like measuring distance and whatnot, or length, or temperature. So if only the hour arm present, okay, then precision would be 1 hour, uncertainty would be plus or minus 0.5 of an hour, half an hour. So it gets kind of strange sometimes. You're loving it, I know. The more examples I do, I think the more you're gonna be like, okay, I get the pattern. I get the pattern. I'm gonna think about it before I write anything down. I'm gonna think about what's the smallest increment, and then you go by that. Okay. Let's do the hot tub next. F. I have a portable hot tub. You inflate it. It's only for the summer. Can't handle the winter. What would be the precision of this? What is it? 1 Fahrenheit. Because remember, if you want a ruler or some kind of continuum, right? Remember, if this is 102, then this can only measure, if it gets any cooler, the water will be 101. If it gets any hotter, it'd be 103. So it's 1. So it's 1 degree Fahrenheit. Uncertainty is 1 divided by 2, so plus or minus 0.5 degree Fahrenheit. Or leave it as a fraction, I don't care. But that's that, okay? Is it possible that the temperature is somewhere in between though? The answer is yes. You know what actually happens? This thing can't be more precise, but if the temperature drops, it's still going to show 102. And then once it's in the middle, it's still going to be 102. As soon as it gets to like 101.4, it probably will show me 101. It can't do better than that, right? It has to like round up or down. So that's the idea of what's happening here. What's the precision of that? It's right there. That's where the precision is found. It's 0.1 kilograms. Uncertainty, divide that by 2. You get plus or minus 0.05 of a kilogram. So if there's a bunch of zeros, it doesn't matter. The device still has a precision that we can gain from, okay, that we can observe. So this is a mix between a picture and just a value, right? Technically, you're just given a value. You're just assuming that that's the case. What's the precision of this? 72.5. The precision is still there. So you turn everything to 0 and just have the Fahrenheit follow it, okay? Uncertainty is plus or minus 0.05 of a Fahrenheit. Let me see. I'm going to keep going. This other one is not very good. I'm not too proud of most of these here that follow. We're going to go... Let's go to 13, question N. Right? It shows the revolutions per minute in the car, right? And here actually you have to be careful. Because what does it say? It says times 1,000. I've never seen something like this, but technically this is 1,000. Can you see that? This is 2,000. Right? This is 3,000, 4,000, and so forth. So every number is technically times 1,000. So how much am I going up by from one marking to the other? 500, right? From 1,000 to here is 1,500. Then it's another 500, then it's another 500. So my precision here is 500 RPMs. So whatever unit is mentioned, that's what you write down. Uncertainty is plus or minus 250 RPMs. If you want, right, we're going up by 500 because the picture isn't the greatest. Don't look too excited, guys. I know you're just gung-ho about this, but I appreciate you're paying attention. That's good. Ruler. We need to know our ruler, okay? Inches, that's the one that we hate the most. I'm going to try to help you out here. It's actually not that hard, okay? If you have a ruler and you notice that it's in inches, right? It tells you here it's in inches. All you have to do to figure out the precision of this one is count from one whole inch to another whole inch. See how many spaces are in between. So you just go 1, 2, 3, 4, 5, 6, 7, 8. There's 8 gaps, right? So the precision is 1/8 of an inch, or 1/8 of an inch. Or if you go 1 divided by 8, what do you get? 0.125? Whichever one you want, that's the precision. So just count how many spaces there are between the 2 inches that you're deciding on. Chances are the province would probably just zoom into that. They would not give you that much to look at. Just there, just count how many spaces, and then you're good to go. Uncertainty, you can divide any of these by 2, but half of 1/8 is 1/16. You double it. Because when you're doubling it, you're actually adding a mark in between every single mark that's already there. Or you take the 1.25, divide that in half, you get that. Watch. You just have to make sure you don't round. It's plus or minus 0.0625 of an inch. I basically just divided that by 2, right, to get my uncertainty. So that's how you do one of those. So could you figure out the one here in P? Can you try that? I'll do my attendance. Figure out, for the next 2 questions, figure out the precision and uncertainty. All right. This one here. 1, 2, 3, 4, 5, 6, 7, 8. So if it gets to 8 to the middle, this is the long, this long mark indicates the middle, so it's going to be another 8. But you probably counted 16 anyway, so your precision is 1/16 of an inch. Okay? Or we already know that that's 0.0625 of an inch. That's how precise this is. Uncertainty is half of that, so it'd be 1/32 of an inch. Or 1/32 of an inch, if you want to write inches instead of 2 ticks, or half of that. That is 0.03125 of an inch. Okay? So which one of these rulers or measuring devices is more precise? You would want to pick this one. Okay? The smaller your precision, the smaller the gap in between a marking, the more precise the device. That even rhymes, right? So I will actually make a note here. This one, okay? Smaller precision equals more precise. That is worth highlighting. That is worth adding to your study sheet, in my opinion, to know a smaller precision. If you calculate it, that's the device you want to pick for a greater precision. What would be the explanation for that? It's a smaller increment. A smaller increment means more precise. Keep going. Okay, one more, and then I'm going to do the actual lesson for today. So here, it's a 3 decimal number. So I'm just going to make sure I have 3 decimal, but the third is going to have a 1 kilogram. Please don't put that number that you see in it in your precision. That's a very common error. So you're so close, but not close enough, right? So make sure that's a 1. Uncertainty, half of that. So I don't know if you already noticed that if you divide a number that ends in 1 by 2, you add a 0 and you turn it into a 5. Okay? So basically, that's how you find out. So if I gave you the uncertainty and I asked you what is the precision, you multiply that by 2 to get to the precision. So read carefully. Okay? Keep going. That one I will do in a bit. Let me just pause here, actually stop.